Okay, so this takes us to our next type of bisector. So we just talked about an angle bisector. Now we're talking about a perpendicular bisector, okay? So here we go. The definition for perpendicular bisector is a line ray or segment that passes through the midpoint of a segment. That's big, all right? So that's the first thing that has to happen, all right, with perpendicular bisectors is it has to pass through the midpoint, okay? The second thing that has to happen is that it has to lie perpendicular to the segment. That's the second thing. So two things have to happen for it to be a perpendicular bisector. One is that it has to pass through the midpoint, and two, it has to be perpendicular, okay? So let's go ahead and draw a picture of it. So let's come here and let's draw our segment. Put your endpoints on there, and let's call it AB. And then what we're going to do is we're going to eyeball the midpoint. And then we're going to draw a line, all right, that comes straight down and lies perpendicular to that segment. So I'm going to draw my line. And because it's a perpendicular bisector, what I know is that on both sides of the midpoint, they have to be congruent. And then those two lines, the ray and the segment, have to be perpendicular. So both components have to happen. So again, we're going to come down to example 1. And it says, what can we conclude if CD is a perpendicular bisector of AB? So here's what I want us to do first. I want to first put our midpoint in there. Okay, so go ahead, put your midpoint. And let's call that E. So what I'm giving you in this question is that CD is a perpendicular bisector of AB. All right, so CD is bisecting AB. So the first thing I know is that E has to be the midpoint because perpendicular bisectors have to be the midpoint. So the first thing I know is that E is the midpoint of AB. And if I know E is the midpoint, then what I know is that AE has to be congruent to EB. Okay. Now the final thing in here, that was the first component of perpendicular bisectors, was that it had to pass through the midpoint. But what I now also know is that they have to be perpendicular. So what I know then is that this line of CD and this line of AB are perpendicular, which means that it's creating 4 right angles. Let's pick one of them. All right, so what I know then is that this angle right here of angle CEB has to be a right angle. So those are the conclusions we can make based off of the 2 components of perpendicular bisectors, okay? Now, just like up above when we did the angle bisector theorem and then the angle bisector definition and then the angle bisector theorem, we're doing the same thing here. Or we just had the definition of a perpendicular bisector, but now we have the perpendicular bisector theorem. So the perpendicular bisector theorem says a point on a perpendicular bisector is equidistant, there's that word again, to the endpoints of the segment. So a point on the perpendicular bisector is equidistant to the endpoints of the segment. So let's draw that picture. So let's start with segment AB again. And then let's eyeball the midpoint. And let's go straight across, label it A, C, and B. And now to make the perpendicular part of it, all right, we're going to go ahead and put this line that's passing straight through C so that it lies perpendicular to AB. So there's our perpendicular bisector. But what we have to do first is we have to then put a point, all right, on our perpendicular bisector because it says a point on the perpendicular bisector, okay? So let's go ahead and name that D. So then it says that point is equidistant to the endpoints. So if I drew the segment, all right, that's connecting D with the endpoint of A and D with the endpoint of B, then those 2 segments have to be congruent.
Well, following Annie Walker,
sorry about this, guys.
Yellow, Tyler Schultz, and Jenna Schultz. That's to the office, please.
Okay, so we're going to go now to example 2. And we're applying the perpendicular bisector theorem. So let's make one small change here, all right, where it says IG is the perpendicular is perpendicular to. Let's change that to EF. Okay. So what it says is IG is perpendicular to EF, so we can go ahead and make that perpendicular. And it says that G is the midpoint of EF. So the first question is asking us, what can we conclude about IG? Well, if it's perpendicular and it passes through the midpoint, what my conclusion is that it is a perpendicular bisector. So IG is a perpendicular bisector of, let's be more specific, of which segment, which is EF. So here we go. All right, let's start with the point I. So it says, what can you conclude about point I? Okay, now I is a point on the perpendicular bisector, which means that if we go back up here, then it has to be equidistant to the endpoints of the segment. So what can I conclude about I? What I can conclude is that it's equidistant to the endpoints, which are E and F. So it's equidistant to E and F, which simply means if I connected I with E and I connected I with F, then those two segments have to be congruent. So IE is congruent to IF. Okay? Now let's talk about point H. Same kind of discussion here. H is also on the perpendicular bisector, which again means that H is equidistant to the endpoints of EF. So it's equidistant to E and F. So H is also equidistant to E and F, which means that if I connect H with E and I connect H with F, then those two segments themselves have to be congruent. So HE is congruent to HF. All right, so now let's apply that. So if you look at example 3, all right, what I have here is AC, all right? If you look at AC, and if you notice just the simple notations, I have perpendicular right here, and I have these two tick marks right here, which means that C is the midpoint, right? So what that ultimately means then is AC is the perpendicular bisector. And if you have a point on the perpendicular bisector, which A is on the perpendicular bisector, that means it's equidistant to the endpoints, which means that the segment of AD has to be congruent to the segment of AB. So the equation that I'm setting up then is simply 8x equals 5x plus 12. And so if we solve that, we're going to get 3x equals 12, which means that x is equal to 4. Okay, now let's go down to example 5 again, because we now have this last question on number 5, and let's take a look. All right, so first thing I'm going to notice is that FH is perpendicular. Okay, that's significant. And then the next thing I'm going to notice is that these two segments right here are congruent. They're both 8, which means that H is the midpoint. All right, and if H is the midpoint, then that means that FH is the perpendicular bisector. Now, if we apply the perpendicular bisector theorem, that says if you have a point on the perpendicular bisector, which F is, then it's equidistant to the endpoints, which means that these two segments right here have to be congruent. So my equation then that I'm setting up is just simply to set 2x plus 5 equal to x plus 10. And if you solve, you should get x is equal to 5. All right, I'm going to go ahead and pause my video here, and then I want you guys to come to example 4 and try example 4 on your own.